Hello, today we are going to learn about different types of histograms. So, as you can see from the diagram, histograms are special forms of bar graphs. The bars in the histograms are connected and are represented by quantitative data, typically continuous. So remember, quantitative means number data, continuous means there's an infinite number of data available, and usually there's decimals involved, so weight, temperature, time, etc. The data is often grouped into intervals, and those intervals are also called bins. So right here, these are your intervals, or your bins. And it's continuous. If we have here a height of 16 to 17 centimeters, whatever the data is, so 16 to 17, and then it's continuous right to the next bar, which is 17 to 18, because you wouldn't be able to differentiate. You can't just say 16 to 16.9, because you can have 16.99, or you can have 16.999, or you can have 16.9999999. That's why the end of one bin is typically the beginning of another bin. Because of that reason, there's discrepancy as to where you would put a value of 17. Would you put, if you had a height of 17 exactly, would you put it in this interval, or would you put it in this interval? Typically, if you have the number that's right on the edge, it would go in the upper category. So if you had 17 exactly, it would go in this interval. If you had 20 exactly, it would go in this interval. So to show the reader which interval that 17 would go into, you use either curved brackets or square brackets. So square brackets means 16 is included in this interval, but 17 is not. So 17 is included in this interval, but 18 is not. 18 is included in this interval, but 19 is not. 19 is in this interval, but not 20. This one has 20, but not 21. And in the last one, this one's got 21, but it also has 22, because you have to have somewhere to put the 22. So when you make your bins, don't forget to use these symbols. So this would be anything from 16 up to, but not including 17. So 16.5, 16.8, 16.9925, anything like that. Then what you do is you put your intervals on the x-axis, label it with the variable, and your frequency goes on the y-axis, label it with frequency. You draw bars that go up to the corresponding interval or frequencies, and make sure there's no spaces. Just like that. Sometimes people label the bar graph this way, or the histogram this way. They'll put a 16 here, they'll put a 17 here, 18, 19, 20, 21, 22. That's another way that you can label the bar graph or the histogram, but it doesn't really matter. So, we're going to look at really how to format your histograms so that it's nice and easy for your reader to understand the data. Generally, it is convenient to use from 5 to 10 equal intervals that cover the entire range from the smallest to the largest value of the variable. If the data set is large, up to 20 intervals might be appropriate. The interval width should be uniform, which means the same. And for formatting, the interval boundaries should be sensible numbers, so avoid decimals. So you'd want your intervals to be like 5 to 10. You wouldn't want them to be 5.5 to 7.9 9, things like that. So try to avoid decimals in the boundaries of your intervals. So these numbers here are your boundaries. Okay, so you're going to avoid decimals. And make them, when I say nice numbers, I just mean if you can get away with like 10 to 20, 20 to 30, or 5 to 10, 10 to 15, then it just makes it easier for the reader to make sense of the data. But sometimes that's not always possible. So if we take a look at this data set, what you want to do is know what your minimum value is and your maximum value. So if you look through the data, the minimum is 18 and the maximum is 33. Now many people make their interval widths of multiples of 5, so they can be a width of 5, a width of 10, a width of 15, a width of 20. So if you did a width of 5, your intervals would be 15 to 20, 20 to 25, 25 to 30, 30 to 35. The problem is that's only 4 bars, and typically we have 5 to 10. If you did a width of 10, well, that would be even worse. So you'd have 10 to 20, 20 to 30, 30 to 40. In that case, you would only have 3 bars. So another way that you can determine the interval is by looking at the range of the data. So our range is, remember, the maximum minus the minimum, and our range is equal to 15. So that means if we want to have 5 bars or 5 intervals, then they would have to be a width of 3, because 15 divided by 5 is 3. So between 18 to 21, 21 to 24, 24 to 27, see, that's a width of 3. And then we'd have 1, 2, 3, 4, 5 bars. Or you could have 8 intervals with a width of 2. So between 18 to 20, 20 to 22, 22 to 24, etc. So as long as you've got between 5 and 10 intervals, you can make your intervals whatever you want. It's best if you make them in multiples of 5 or 10, but if you can't, just as long as you do it without decimals, it makes it much easier for the reader to make sense of your data. So we talked about this. Data that appears to lie in between 2 intervals would be placed in the higher interval. For example, if your intervals were 18 to 21, 21 to 24, the value of 21 would go in the higher interval. So as I said, you would indicate that using the square brackets means it's inclusive, the curved brackets means it is not inclusive. There are 2 special types of histograms that we're going to go over. Please put a star beside these because these are the types that you're most likely going to be graphing on a test or a quiz. The first type is a relative frequency histogram. The word frequency may or may not be there. It may just be called a relative histogram. Now, it has the same shape and the same horizontal scale as the corresponding histogram. So if you took a look at the first histogram, the x-axis is the same and the size of the bars are all the same. The only difference is that the vertical scale measures the relative frequencies, which are the percentages, rather than the absolute frequencies, which are measured as a count. So your regular histogram, your bar would go up to a frequency of 3, With a relative histogram, what you're going to do is take that 3 and convert it into a percentage. So if we know that there is 195 pieces of data, 3 divided by 195 gives you 0.015, and that's how high your bar would go. The next one, 8 divided by 195 would be 0.041. And you would continue that with all of your frequencies. Once you have converted all of your frequencies into relative frequencies, you can change the y-axis to be the percentages or the decimal form of the percentages. And to check your answer, your total should be 1. So that is a relative frequency. It just puts the percentages instead of the absolute frequency. A cumulative frequency histogram. Again, the word frequency may or may not be there. It might just be called a cumulative histogram. It describes the number of data entries that are below a certain value. The cumulative totals are marked on the vertical axis. So for instance, the first bar between 16 and 17 had a frequency of 3. So the height of the bar is 3. The next bar is going to take the 3 that there was before and add the 8 new observations, and it would have a height of 11. The next bar would have the 11 previous observations, add the 34 new ones, and that would go up to a height of 45. And this pattern would continue until you get to the end. And your last bar would represent the total height of all of the observations. So those are the two special types of histograms that you need to know how to graph. So please make sure you study that when you study for your test or quiz. If there's any questions about histograms, please make note of it and ask your teacher during the next class. Thanks. Bye-bye.